you say. All right. Good morning, everybody. This is the first of the session in hardware management. We have a couple of hours with 4 talks in here. The first one is on OCP profiles for hardware management. Followed by that, we have modeling of immersion cooling using OCP profile. And then we have a talk on tools and process for how you generate these profiles. And we'll end up with OpenBMC update. So that's the agenda we have. The first talk is, I'll introduce myself, Hamel. I'm the hardware management co-lead in OCP, and I'm lead architect of Ethernet controller products at Broadcom. John?
So my name is John Leung. So I'm OCP incubation committee, and I'm the liaison to the hardware management group. I'm also principal architect at Intel.
All right. So in this talk, the way it's structured, first we will introduce Redfish, which is behind the OCP profiles, and then we'll go over the OCP profiles for hardware management. I'll cover the first part and then hand it over to John. So as you know, DMTF has released Redfish standard for more than 4 years now, almost 5 years. The idea behind Redfish was, at that time, with the modern data center, you want to have an external-facing programmatic interface which leverages the RESTful principles as well as your standard HTTP transports to allow a client to manage systems. It started with compute system, and then you will see later on, we'll talk about how it has expanded. But that's the idea. It is meant to serve today's need from the IT standpoint, make it simple interface, which one can use. Here is an example of how easily you can get some of the Redfish data by using a simple HTTP client and then writing a Python program around it. So that's the idea behind Redfish standard. It has built into it, the schema is all based on JSON with OData annotation. And then everything is based on resource. So you use the resource URI, and then you access those. Based on that, you get the response, whether in the response you get properties data, as well as we'll see you can also get some complex set of properties and actions. So that's very high-level view of what Redfish is. This is a little bit more detailed, showing you an example of what everything starts with service root. And then in this, you see both physical view and logical view. Physical view is the chassis, and then you have logical systems. Each system has processors, memories, networking, and storage. And you also have within the service the managers, which are used to manage the systems as well as chassis. And you have the services associated with that, which manages the management session, as well as you use the accounts to manage the specific set of system, and then there are associated username, password, and account settings that go along with that. So that's a very simple representation of a Redfish service and the model associated with that and all the objects. What you see on the right-hand side, which shows you how a JSON response looks like. So this is when you retrieve a computer system object. You get some of the simple properties. There are 5 different types of things you see in there. The simple properties would be, this is where you get a value for a given property. For example, you get the part number, serial number, UUID for that. Then you have a set of complex properties, which for the example you see in here is your state of the system, which is composition of whether the system is enabled, what's its health, what is the overall health in terms of roll-up. So that's where you start seeing those type of complex property where you have an array of properties inside. And then you can see within that system there are subordinate resources. This is where the containment comes into picture. You see in here the processors, memory, the network interfaces, the storage. That's all shown as those subordinate interface. And then you can see each one has its own ID and URI. And then it shows how this system is associated with. This is where the physical chassis in which the system resides. You see its associated resources. Also, it's managed by one of the managers here that's shown. And then the last piece you see in here, not all the objects have, but in this object you see the actions. So these are the actions that you can perform on specific object. In this case, the specific action you are seeing as URIs, it allows you to reset this system by using that target. You see that as an action. So this is an example of how when you use Redfish service, try to get object response. This is how a JSON's response looks like. And as I said, primarily you see the 5 different types of categories you see in here, the simple property all the way up to the actions. So the first piece here is when Redfish started, it started with the compute model. So what was modeled in there started with the whole inventory information. This is where the chassis information comes into picture, the physical aspect, what this system manufactures about, what's the current state of that. And then you have some of the control and monitoring aspect. This is where all the power control of the system, ability to turn on, off, recycle the system, boot control, ability to configure the BIOS settings. Those are all part of what's defined in there. Within that system, you also have a bunch of devices, which includes the network interface, storage interface. Those are all built into the model for the compute. So that's your inventory monitoring control type of capability. Now, in order to manage this kind of management infrastructure, you also need to have in the model built in the management controller settings, ability to configure that, ability to change some of the security settings. So that's all part of the compute model. You also want to see where the system resides within the hierarchy, whether it's in the management hierarchy or within the physical hierarchy. So those are also part of discovery that is built into the compute model. And then you have the security settings. Security is becoming more and more important. So HTTPS basically gives you that underlying transport level security. In addition to that, the model has roles and privileges defined. So what this is you can have one or more management accounts, and then each account can have different roles. And depending on role, you allow it to perform specific management operations. So you can have a role of admin, which only allows one to get read-only data and not alter any data or not perform any action. Or you can have a super admin, which has right to do anything with all the objects that are exposed. And so that's all the modification, basically all your CRUD operation. With any management, you also need to have some kind of eventing model. Redfish compute model has built into eventing model. It's based on subscription. You can subscribe for event, as well as there is event log maintained, which you can access. That's the pool model. So this kind of eventing, if you recall what used to be cell kind of event logging capability, this is much more sophisticated than that. It allows you to also access this either out of band as well as through the host interface in band. Redfish has defined also the host interface, which allows one to talk to a service from the local host. And then finally, we added some of the composition model here. So you can take this kind of compute model and create a specific compose system out of it. And it could be also constrained where you allow it to be composed in only a specific fashion. So these are all the capabilities that are in current compute model. So we started with that compute model. This, what I want to illustrate here is the model has been extended quite a lot in last 4 or 5 years. And then John, who is our VP of Alliance at DMTF, has done a fantastic job at reaching out to a lot of this organization and then getting them to adopt Redfish and Extend. So adopt and extend has been our theme. So we started with first storage. This is where SNIA and NVMe Express comes into picture. Then we have work in progress model we released based on IETF model of Yang to Redfish mapping, which allows you to now extend this to Ethernet switches. And we were just talking about there's interest in doing this. So that gave that extension. Then within system BIOS interface, how you manage the BIOS in the UEFI environment, that also has now built-in support for Redfish. What has happened recently is we got a lot of interest from the operation people. This is where GreenGrid, ASHRAE, they came back and say, we want to model also the power, cooling units, and all the operation facility that they want to model and extend the Redfish. So this is where that alliance was formed. And in last year, we also saw significant interest from completely different domain. This is where PICMIC approached us with industrial IoT and said, okay, in this environment, for us, it makes sense to model the sensors as well as equipment on the floor and extend the Redfish model. So that's fairly recent. And then on the other domain where you can think about broadband, where people are talking about CPEs, customer premise equipment, they want to model that environment also using Redfish and extend the existing model. So in summary, as you can see, we just started with compute model, but it has grown significantly across, and it covers a lot of data center aspect, and it has gone beyond data center where it has reached into industrial IoT and some other environment. So that's quick overview of what Redfish is, what capability we have, and how it has been extended. For rest of the talk, what we are going to focus on how OCP has leveraged this and what we call OCP profile, which is adoption of Redfish as well as purposing it for the OCP platform. And I think I'm going to hand over to John to cover from here onward. Go ahead, John.
Okay. So hardware management project includes the rest of the projects within OCP, and we actually kind of nice version. That helped. Okay. Yeah. So we actually presented this slide last year, and I'll show you some of what we've done and the progress we've made so far. But basically, the hardware management project would create a baseline profile, which would define a common. When you guys actually open that back door and prop it open, they keep closing it. Just open it, and there's something on the ground to prop it open. Thank you. So I'll review some of the progress which has been made during the last year. So each individual project could then extend from the baseline. So the baseline lays the claim that if you find an OCP platform, they will have some common manageability, and it will be a baseline set of manageability. And from that, each platform, depending on its specifics, whether it's compute, storage, or network, would have additional manageability based on that platform's function. But it was totally up to the projects to decide how to go do that. We went to the server project, and we actually seeded them with a profile that they could extend for servers, and I'll show both the baseline and the server profile next. So why OCP profiles, and why profiles at all? So one, a profile file is basically a JSON file. It's a JSON file because it needs to be machine readable. And it specifies the URI, the properties within the JSON, and possibly the values of those properties within the JSON packet, which is returned. It is the prescriptive semantics on top of Redfish. So Redfish attempts to describe everything it possibly can. The prior slides showed its expansion into other management domains, but we don't want people to implement all of it. So prescriptive powers like OCP, which says we have OCP accepted. In order to get an OCP accepted, you need to have these specific resources, these specific properties, or the prescriptive powers that can actually align the industry to go in this particular direction. So we created profiles to allow organizations like OCP to write down what the requirements are. Not only that, but in order to deal with the back end of once you set these requirements, how do you make sure the industry has conformed to them? We've also built stuff on that side with the validator, because the first thing people are going to ask if you say you have to do this in order to get an OCP accepted sticker, they're going to say, so what conformance test do I run to get a thumbs up that we in fact do pass this? So what the DMTF has done is actually built a validator in the back end, and it reads this JSON file, profile, and auto-generates the test and runs the test and gives you a pass-fail. That's the back end of what the DMTF has created, is a process where an organization like OCP could define what its requirements are and then guide people, implementers, to actually to a set of conformance tests which actually tests what OCP requires. So, however, the validator is only a part of the conformance test suite from the DMTF. As I mentioned, the validator only tests the existence of the resources and the values, but there's a whole lot to test within the REDFIS specification and the actual services that need to be checked. So in the prior slide of the resources, there's not only REDFIS service route, but then there's event service, there's task service, there's job service, there's log services in there, and all those need to be tested independent of the resources which are in Chassis Manager and systems. So the DMTF has actually created a suite of tests to test all this. It has a framework that actually wraps all these tests together. So you run the framework runs these tests and gives you a single unitary pass or fail on it. All these are open source. And on the link, there's a GitHub DMTF where you find all this. So current status. So status is that the baseline profile was approved at version 1.0. It's currently posted at the hardware management profile, hardware management project profile site. In addition, we've created within the OCP GitHub a OCP profiles repository. And that's where we're going to basically place all the profiles, and we will edit and merge the changes to those profiles there. Because it's a JSON file, it's best to do it within a GitHub so we can figure out what the changes are coming in. Previously, we've passed the JSON files around, or we've tried to edit them within the working groups, and that became a bit more difficult than do it this way. Okay. In addition, we went to a server project. We gave them 0.02. In the middle of last year. They have not actually proceeded beyond that, so we're in the process of trying to convince them to go ahead and take it to 1.0, make additional changes to it since then. So we'll probably do that on the GitHub at this point. In yesterday's announcement, we have Intel, which has donated RM source code. The Open RMC project, which is defining a rack manager to manage the rack, will also have a REDFIS profile. That REDFIS profile will have requirements on what REDFIS objects need to exist. And those will also, so there will be a profile which will define what the Open RMC will be. So we now take the Open RMC can now take advantage of the test structure that exists, because we just have to write yet another profile and then guide implementers of rack managers to run that profile within the system. Okay? All the other projects. So all the other projects, they expressed it last year, they continue to express it this year, is that they have interest in creating platform-specific profile extensions, but no profiles have yet been proposed from them. So it was interesting, just prior to this meeting, I was talking to someone from the telco group who was interested in extending the profile, and that's basically based on customer input, right? So we can sit there and draw this diagram all day long and say it's a great thing to do, but no one's going to pick up a pen until some customer asks for it. So at least in the telco arena, the telco customers have come back and said, you really should extend this baseline profile into telco. I think they're looking at switches at this point. But it's going to be customers that drive this. It's not going to be us in a room trying to invent things. So as customers in each of the platforms decide that they want manageability, they will extend it. What we're doing at this point is that a lot of the specifications that are coming through the IC, we're asking at least for a statement on manageability. And because some of them have totally lacked any statement on manageability. And the first statement is that manageability will be RESTful, that manageability will be Redfish, and then eventually that manageability will conform to the specific profile. A number of the projects have just said baseline. So I went to all the projects and I said, if you haven't got time to specify a platform-specific profile, just reference the baseline, right? Because everyone's going to start at the baseline anyway. And as you go create your platform-specific ones, you can repoint them to your specific profile. So you'll see as some of the specifications come across, they will all reference the baseline profile. And that's to kind of align the industry to start running the conformance tests against the baseline. When we did the baseline, we set the bar fairly low, and that was to get everyone over that finish line fairly quickly, that they could go through the process and be fairly certain that they will pass the profile. In addition, the baseline has to go across all the platforms, right? And so anything that gets added to the baseline needs to be kind of approved by all the platforms, that this is going to be imposed on each one of them henceforth. So just a quick look at what the profiles look like. So the hardware management profile talks about chassis and managers. It actually doesn't talk about systems as much. Those are left to the actual platform groups. So everyone is in a chunk of hardware. So we call those chassis. Chassis are managed. So chassis have power and thermal objects, and managers have possibly a management network, which we manage, and a protocol, and then usually accept log services, and then accounts, as we mentioned earlier. So this is the drill down of the chassis resource. The way we've constructed it is on the left-hand side is the bold face is what is required. The non-bold face is what could have been required, but we decided not to. And this was as I went to the server group to say, we basically pick some subset, right? And so if the community decides that there's additional requirements they want to impose, they can quite easily flip these over and make them required. But I didn't want them to just see, and so if you look at the chassis profile, it's actually much larger than this, but I've given them the opportunity to know what could have been and the subset that we selected for the baseline. And so once you have the baseline profile, now you can extend it to do a particular platform. So we went and did server so we could prove to them that this all works. So the server profile can reference the baseline profile. So all you need in the server profile are those additions to the server. And for that, in that case, it added systems. And systems, as we mentioned, has subclasses for processors and so on and so forth. But it also had log service and Ethernet interface. So the only requirements that we have actually at the system level is the summary processors and the summary of memory. And we don't have to go into detail as to exactly what those subordinate classes have to be. So my call to action is fairly simple. So baseline profile is out there. Companies should start testing performance to that baseline because that's going to be the basis for all the additional profiles. Approve that server profile. So it's been sitting there for a while. I've actually talked to a project lead. He has no problem doing it. I just haven't had time to go there and make the request to get to 1.0. In addition, Jeff Otto has found some errata in there that needs to be fixed before we actually take it to 1.0. So the comment I had made that you missed was that it's now on a GitHub. So the profiles are now on a GitHub, so you can actually make the modifications and we can merge it like a normal GitHub should work. And then propose specific profiles in other OCP projects. So I'm glad to hear from Telco that they're looking at it. I've been waiting for storage because the members of SNIA have promised me that they would join and propose a profile within the storage management group. And then in the designs, this is for the project leads of the other projects, is specify Redfish, and then specify the required profiles as they develop them. Okay? Any questions?
All right. Since I'm also moderating, anybody has any question for me or John? Okay. In that case, let's thank our speakers.
Yeah.